Hello everyone, I welcome you all on this course on Analysis of Structures, a Numerical Approach. Today we are going to start our lecture number 5, which is entitled Gate Problems on Method of Joints and Sections. So as many of you might be knowing, GATE is a very prestigious exam meant to check the engineering aptitude of engineers, and it is a gateway to entrance into IITs and IISc for MTech programs, and it is also crucial for going to various PSU jobs. So it is very important that we do the practice of problems which have already come in GATE exam based on the topics which we have discussed so far. So I'm your instructor, Professor Gaurav Tyagi. I'm an associate professor in the Department of Civil Engineering at SR University, Warangal, Telangana, India. So let's begin. So here is your first problem. You have been given a simple truss and you have been asked to find the forces in member A, in member B, in member C, written with small letters, and an external loading is there, which is P force downward being applied at member A. So you have to find forces in these members. So which way we should proceed? See, one theorem we discussed, that theorem is directly applicable here, that if there is a point and three members are passing through it and the force is applied along the third member and the two members will have equal force, let's say F dash and F dash, and this member is going to have directly the force which the external force is there. So A member will have directly a force P. So I can directly say that either option A or option C might be correct. So now let us proceed for other members. Okay. I can also say that whatever the upward reaction force will be applied at this point, it will be directly taken away by this B member because of the fact that C is a horizontal member, right? So if you do force equilibrium at B joint, in x direction, this will be some Fc and you will directly write Fc equal to 0. Okay. So out of these two options, directly I can say that this is my correct option, even without finding my force in member B. Okay. So this is how we can solve this problem in a fairly simple manner. So now, if you want to find out force in member B also, then you can apply moment equilibrium about this A point and you can do summation MA equal to 0. If you do that, you will get P into L is equal to VB into 2L. So your VB will come out P by 2. So we have confirmed that this option is correct. So in the gate problems, many times we will find that they are checking our conceptual understanding rather than our calculative rigorousness. So if you would have gone for directly applying method of joints, then you would have first found the support reactions, which are three in number VA, HA, and VB, and then you would have solved for this member and this member, and then you would have come to this joint, and then you have solved for this member and this member, and then you would have moved on to this joint, and then you would have found for this member and this member, and then finally you would have come to this joint and found for this member. This would have taken at least 5 times more time than what we have used this time. Okay, so the theorem part which we learned was a simple fundamental which helped us to directly find the force in member A very easily just by looking at the problem. Okay, similarly by looking at joint B, I could say that the force in member C is going to be 0 because horizontal force is 0, external horizontal force is 0. So, and little bit calculation, this one line equation solving was required only for B joint. Okay, so this is how you have to be extra sensitive and careful while reading the problems of GATE exam. So let us proceed to the second problem. Okay. Second problem, you have been told to ask the force in the member DE of the truss shown in the figure. So when you look at the figure, you have to carefully analyze the figure first and see if you can find out certain member forces just by the use of theorems. So if I see the joint C, I can say that the force in this member CD member and the force in member CA is going to be 0 because there is no external force. F external is 0, right? So this member will have 0 force, 0 force. When this is done, then you have to find force in member DE, and to do that, you can directly look at joint E. If you directly look at joint E, you will find that there is no external force acting on joint E also, and thus the force in member ED is going to be 0. Okay, so directly my B option is correct. Okay, so you can see that gate problems are simple. They are checking your conceptual understanding, but the important thing is that where you begin your problem from. If you begin your problem from this joint, then you will have to apply method of joints a couple of times, and for applying method of joints you have to also find out support reactions, and that will take your valuable time during the exam. So you have to see cleverly from which side you have to find out the member forces, because the same member DE, if you look from D side, it is a complicated solution, but if you look from E side, the solution is not even one line. Okay, directly you can tick the option as 0. So this is how you have to utilize the fundamentals of truss analysis in solving the gate problems. Let's come to the third problem. So in the third problem, you have been given a simple truss and you have been asked to calculate the force in member QR. So if you find the force in member QR, um, okay, okay. So see, in this case, both the joints are pin jointed connections. So both of them are going to have vertical and horizontal reactions. But what I think is a good approach is to cut a section from here that will expose three forces, this, this, and this. Now I'm hopeful that I can apply method of sections to find out the force in member QR in one line. To do that, let me do the moment summation as 0 about T point. Okay, T point. So about T point, if you do moment equilibrium as 0, you will write summation MT equal to 0, and consider the RHS side of the figure, right hand side of figure. If you do that, you will find FQR into L. This is your lever arm distance. L is equal to P into L. Okay, this is the lever arm distance for force P. So from here I can find FQR is equal to P. Okay, so this is how you can see that important thing is to carefully think before starting the problem which method to apply. In this problem, I did not go for method of joints because of the fact that calculation of support reactions is very difficult, because there is no roller support, both are fixed support. So there are four support reactions which I cannot find with my present knowledge, and but the application of method of sections was much easier. So always try interest analysis problems if you could somehow apply method of sections, because method of sections give you answer in one line Whereas in method of joints, you have to apply the same calculation again and again repeatedly for multiple joints. So in this case, you could directly find the solution using method of sections, and therefore it was a 1 mark question. So now we are having a little more difficult problem. It is having multiple panels and it's a simple truss, and you have to find out. Let's read the problem statement first. It says that the pin jointed to the truss is loaded with a horizontal force of 15 kilonewton. Here is my force 15 kilonewton at S and another 15 kilonewton vertical force at joint U. As shown in the figure, find find the force in member RS. Find the force in member RS. This is your member RS in kilonewton, and report your answer taking tension as positive and compression as negative. Okay, so you have to find out force in this member. So tell me which method you are going to apply. Should you apply method of joints or you apply method of sections? Purposefully they have given both the joints as pin jointed because it will have 4 reactions: VT, HT, similarly VP and HP. Now this becomes a complicated problem because finding the support reactions will be difficult. So let us apply method of sections. For that, you have multiple options to cut, but the simplest one would be to cut the truss like this from the middle. And you have to choose which side you will go for. See, there are two sides of the truss. One is this side, other is one is the left side, other is the right side. So you have to choose which one you want to go for. Okay, let us try the left hand side. If I try left hand side, so this is a complicated problem because if I do moment equilibrium about this point, I will have this as one external force, this is my second external force. These two are fine, these two will be zero, and I will have this Vt and I will have Ht. Okay, so Ht moment will be zero. So I'll get an equation in terms of Vt and Vt and Rs. Okay, and if I do the force equilibrium about T and Rs. Okay, can I find Vt in some way? If I do horizontal force, so 1, 2, 3, 4, 5. Okay, support reactions need to be found out. Moment of external force in support reaction. So somehow Ht will be 0, but Vt will not be 0. So can I find Vt directly? Somehow, if I do moment equilibrium about this point, then if I do moment equilibrium about P, then I will get an equation in terms of Ht, Vt, and yeah, Ht and Vt. So pin jointed to the truss loaded with horizontal force and horizontal force, find the force in the member RS and report your answer like this. Okay, so think which one we should do. and then can I calculate this is let us see how many unknowns we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And joins 1, 2, 3, 4, 5, 6, 7. 7 joints. So M plus R is equal to 2J. It is a determinate truss. One, two, three, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. M plus R equal to 2J. So should be able to find out. Okay. Let us go back. I can see the member force in QR is 0. This is 0. Okay. And this is 0. This is going to be 0. Okay. This will be VP2. This is also going to be VP. Okay. So many forces we have found out here. So if I remove this part of the truss, which is 0. Okay. So this is gone. This is gone. This is gone. Okay. If this is gone, then if I do this is not there. Okay. So this is not there. Okay. If I do vertical force equilibrium here, I will get an equation in terms of Vt and this member. Okay. Yes, this equation. So let us now try out. This is my FRS and this is my FRU and this is my FVU. So if I do summation Fy equal to 0, that means FRU cos 45, this angle is theta, FRU cos 45 Vt equal to 0. This is my equation number 1. Second equation I can write horizontal force equilibrium. So FRS plus FRU cos 40 sin 45 FRU cos 45 plus Vt minus 15 equal to 15 is equal to 15. Okay, this 15, this 15. Okay, and if I do this is summation Fx equal to 0. If I apply this, I will get FRS plus FRU sin theta is equal to 15 plus ht. And if I do moment equilibrium, about this point, okay, then I will get an equation in terms of FRU and FRS. So if I extend this backwards, this we need to find out if this is theta, this is 90 minus theta, so this is theta. Okay, so this length is 4, this length is B, so B by 4 equal to 1 by root 2, so B is 2 root 2, this B length. So if I do moment equilibrium about this point, I will get FRU into root 2, this is clockwise, plus 15 into 4 minus FRS into 4 minus 15 into equal to 0. So this gets cancelled out. My FRU comes FRS by 2 root 2. My FRU is root 2 FRS. So now if you put your aim is to find FRS. Okay. So 3 equations we have applied and we have got 3. So you can put this equation back in this equation. So you will get FRS plus FRU, which is root 2 FRS divided by root 2 is equal to 15 plus HT. So FRS equal to 1 by 2 times of 15 plus HT. And can get another equation. But let us solve this problem after a while. Let us proceed to the next problem for the time being. Okay. So the mathematical idealization of a crane is a 3 bars with their vertices arranged as shown in the figure with a load of 80 kN hanging vertically. The coordinates of the vertices are given in the parenthesis. The force in the member QR will be. So you have been asked, so here is a roller support which we cannot see. Okay. So this is a fixed support, I mean the pin support, and this is a roller support, and you have 3 bars with you. So you have to find out the coordinates of the vertices. The force in the member QR. Okay. Force in the member QR you have been asked. Okay. So to calculate the force at the section here, and you at a section here, you will get an exposed force. Look at a section here, one exposed force is this, another exposed force is this. And if you do moment equilibrium about this point, it will be a bad idea because you will get 2 unknowns. If you do horizontal force equilibrium, you will get an equation. Okay, so directly apply the method of joints here. Okay, method of sections is not helping us. So if you apply method of joints, you will have VR and HR, and here it will be, you will be having VQ. Okay, so you can directly find VQ by doing moment equilibrium about point R, you will get summation MR is equal to 0. That means VQ Q into this distance. This distance is given to us or not? This distance is not given to us. This, let's say A. No, distance is given to us. 310 coordinate and 30 coordinate. You can see here the coordinates are mentioned. This is 10, this is 30. So this length is 2. Okay, and this is 0 comma 4. So this length is 4. Q into 2 is equal to 80 into this distance. This angle is, this small angle is 90 minus 22.84. 90 minus 22.84. It is 67.16. And this length I know. This is 0 comma 4. So this length is 1. Okay, so directly you can find the mm, actually you can directly find out this is 1 and this is 2. 80 into 3. So your VQ comes out to be 120. Okay, VQ is 120 kilonewton. And then if you know VQ, and then you can find out the force in member QR. To do that, you can do force equilibrium at joint Q. At joint Q, you can write this is FQR, this is FPQ, okay, and here is a force VQ, okay. So you have to find out force QR. So you have two components of FPQ. This is FPQ, and this angle will be, the small angle will be 90 minus 104, 104.03, and this is 104.03 minus 90, which is 14.03. So this is FPQ cos 14.03, and this is FPQ sin 14.03. So Q plus FPQ cos 14.03 cos of 14.03 is 0.97. Okay, so this is 0.97 equal to 0. Okay, so from here you can find out FPQ, which is minus 120 divided by 0.97, and FQR is equal to FPQ sin 14.03. So this is minus, this is minus 120 divided by 0.97 into sin 14.03. Sin 14.03. Sin 14.03 is a 0.242. So let us calculate this. It will be 120 into 0.242 divided by 0.97, 29.9. So almost 30 kilonewton with a minus sign. So first option is correct. So in today's class, we saw a few problems based on GATE exams. And the important thing in these problems is to first of all find out which method to use, and then we have to find out which is the shortest possible way to solve that problem. In the next class, we are going to see some more problems based on GATE exams. Thank you very much. Let us meet in the next class. And I wanted to discuss one more thing, that in most of the problems which you will find in competitive exams, you will have to apply a combination of method of joints and sections. So it's not necessary that some problem should be solved by method of sections only, or some problem can be solved by method of joints only. Most of the times you will have to use a combination of both the methods. So this is something we should always keep in mind. Thank you.